Finding the inverse of a 3x3 matrix is a notorious bottleneck in linear algebra. It is a calculation that takes a lot of time and rigorously tests your patience. This textbook page shows the traditional starting point. To find a minor, mentally isolate an element, cross out its row and column, and calculate the determinant. You repeat this 9 times. Then map an alternating checkerboard sign pattern over your results to find the cofactors. Finally, you have to transpose that whole grid, flipping the rows and columns. Keeping track of all these moving parts and negative signs makes it incredibly easy to make a basic arithmetic mistake, especially on a timed test. The standard algebraic approach is essentially an endurance test that invites human error. To get through these problems quickly and accurately, we need a radically different visual solution. To find the inverse of any matrix, we only need 2 components: the adjoint matrix, which sits in the numerator, and the determinant, which sits in the denominator. This reference shows Sarris's rule, a visual shortcut for calculating the determinant. Duplicate the first 2 matrix columns on the right. Multiply entries along the 3 downward-pointing diagonals and add them together. Then, multiply the 3 upward-pointing diagonals and subtract from your total. This linear visual method locks in our determinant in seconds. With the denominator solved, we can focus all our cognitive resources on the much harder target, the adjoint matrix. The real challenge is building that complex adjoint matrix without writing out 9 separate, tedious 2x2 minor equations. Build your new grid starting at the center element. Loop vertically, center, bottom, top, center, stacking these as your first column. Repeat this exact loop for the right column, then the left. Finally, duplicate your first column on the far right, creating a 4x4 grid. By translating the numbers spatially, we have completely bypassed the confusing checkerboard sign convention and eliminated the need to transpose the matrix later. This new 4x4 grid is perfectly arranged to let us calculate the final adjoint matrix using only basic arithmetic. Look at the top left 2x2 square of your new grid. Cross-multiply those 4 numbers and subtract. That single result becomes the first value in your final adjoint matrix. Next, simply slide that 2x2 frame 1 column to the right, cross-multiply again, and record the next value. Moving this frame methodically across the rows and down the columns will rapidly autofill the rest of the matrix. With the adjoint matrix complete, you just divide the whole thing by the original determinant we calculated back in step 1. Turning this calculation into a spatial pattern recognition task strips away the algebraic friction, letting you find the inverse of a 3x3 matrix accurately and in a fraction of the time.